Okay, so I just got done editing and uploading video. This goes to the JK BMS. This is the comms board that comes out through these cables here. This one is RS-45 CAN, RS-232, and these are RS-485s. So I need to make a cable with RJ45 ends, which are these guys, to go from the pin out here to the summary inverter. And I'm going to be using RS-45 between these two. So I got to grab pins 5, 6, and 7 or 8. So I have a ground and RS-45A and B. You got to be careful when you do this because it does look like on the inverter when they put VCC available at this plug. So RX and TX I'm not going to use. I might use that later down the road with RS-232. That also applies here. I might at the end of the day stick a microcontroller that talks to my home automation server that pulls data from here and here and packages it and sends it over the network. We'll see. That's a down the road thing. I'll have to figure that out and make a video for it. But I have my two ends and some cable, and then I got to get the pin out. So it looks like on this plug here, pin 1 and 8 is RS-45B, and 2 and 7 are A1, and then pins 3 and 6 are ground. So basically it's going to go from ground to ground, A to A, B to B. And then I bring them out and I have cable, and so I cut a piece of cable off, so I'll get that set up and make that and go from there. These have little pull strings in them, so you don't nick the lines. Once you get it and you get enough of this pull string out, once you get it started, if I can actually do it, it'll actually split the sheathing like that. So then you can just cut this back without worrying about putting a nick in here and causing it. I'm in here at my solder station. These I gotta make up the BMS balance leads, and basically these ring terminals I have to crimp on, and then I'm also going to throw in a little dab of solder on the very ends of these to make sure they have a good solid connection. So these are not quite long enough to fit through. Pull that off. Yeah, I don't like that. So, stick in these guys. On these BMS balance leads, they also have NTC, so you can put temperature probes. So I'm going to end up using all of them, but the unused wires I will coil up for now, because I want to put temp sensors in many places as possible. I'm pulling off this heat shrink boot. It's not going to make a difference for what I'm doing. I have other heat shrink I could slip on and use, but I'm just... come to get these BMS leads hooked up. So I got most negative over here, most positive over here, so I'm going to start over here. I'm going to peel this kind of back, and then just be careful. One of these is marked number 1, that's number 2. So we'll set this guy aside. And this guy needs to go to the most negative. I guess I probably should have put the balance leads on before I put this on, because I gotta get a screwdriver under here and that's gonna be a little more difficult. Hey Penny. Hey baby. Get on. Yeah, I'm gonna go grab a, how do I want to do this? Probably a socket so I can get in here. In theory, there's nothing live here, but it's one of those things you want to be safe about. Probably, let's get you just need to swipe a screw from here. That way I can go check them, get the right socket. Alright, so I need a 10 millimeter. I'll grab one. So on this last one, it requires a second line. This is the BMS power to power that up. So I gotta get the balance lead and this end. I made this off camera. This MFCC, I'm going to use some Kapton tape to put it to a bus bar. That way I have the temperature measurement of the bus bar. Yes, hi Penny. Taped the temperature sensor to this bus bar right here, so that way it reads the temp. This can take a total of 4, so I'm probably going to at least coil up these big loops of wire just so I have these temp sensors. I might put one, I'm thinking maybe one on this bus bar, or on this wire that feeds out, one in the middle of the pack, or edges of the pack, middle of the pack, and then that way allows the BMS to get a good temperature reading of the whole pack while it's running, to, in the event there's an issue, we can catch it before bad things happen. tape, cut the ends off, leaving just this NTC for temperature sensors. I'm gonna do the same thing to the other one. Kind of just push that up in the heat shrink. That way it kind of gets a wire temperature. Now I want to just do a check. I'm going to put this on DC, and I'm going to start at my lowest string, which should be this guy with the number, that's number 3, so I need number 1. And I should be able to walk up these pins that are exposed and measure the voltage to make sure that I don't have a wrong jump. It should jump by around 3-ish volts every time. So I don't know how I'm going to be able to set the meter up so you camera can see it and I can. I can try to put it there and then okay, so everything voltage wise seems to check out. So I got a little bit of adjustment to do here because let's see. I want to tape this wire up for now since this has live power to it and it's just kind of dangling. I was making the cables, I talked about how I made one longer than the other. That was so we could do that. Yeah, you can see that. Hey, no magic smoke has come out yet, so that's a good sign. And I have to go look up what these means on. I think that's the alarm because probably something's not right at the moment, but we'll have to go pull up the app, see what the app says. A little bit of cleanup and then I'll pull up the app. Okay, pulled up the app and I believe the default password, let's see. Hey, there we go. So we see all 8 cells. We're throwing an alarm. Let's go check with the alarm. Okay, it's saying cell count's not equivalent to what it thinks it is, so we have to go do some settings. So cell count, yeah, it thinks there's 16 cells and there's not. It's 1, 2, 3, 4, 5, 6. Verify. Cool. So now it's saying, so let's go make some changes. Cell count 8. Oops, 8. Hit OK. Amp hour capacity 300. I think I'll leave those other ones alone for now. So now why is there a battery's fully charged? Why is that an alarm? I think 3.65 is what it's supposed to be per cell max. Okay, let's go to control. I'm going to disable the ability for it to put out power and charge for right now. I'm going to have to go look at settings because I don't know what all the settings I need to put. Oh, advanced settings. I remember there was something in advanced settings for lithium iron phosphate. So I think I'm going to have to go look at those in order to figure out what's what. To be on the safe side. So I think at this point now, I'm going to lift this up, make all these connections. So in theory, there's no power even if I flip this switch because it's off in here. So we should be able to test that. I might as well go ahead and do that now since the camera's on. So I've disconnected the grid side just because the grounding terminal I'll need to run out of the panel, but line and neutral are hooked up, battery's hooked up. I'll hook up the COM port here and then mount and then hang it, and then we'll do a power on test, see if it works. And then I'll redo this, probably do a switch right here so I can turn it on and off to charge off the grid if I need to. Alright, let's go to the controls and we will allow it to discharge now. It's working. Well, I don't know what that buzzing noise is. Probably making power. According to this, it's pulling 800 milliamps. So let's go into the settings here and see if it will. Actually, we can do a test. I have a heater right here. Let's put it on the fan. Nope. So something's not right. Oh, breaker might not be on. Let's try that again. It's on. That's just a fan. I'm not running any heat because it's warm, but let's see what the app says. So 1.6 amps is what we're pulling. Alright, we're getting sidetracked. We gotta test something here. So we gotta go, let's pull the, need to pull the instructions to see if BMS communication on this is working. Lib 485. It's probably going to throw an error because I don't think I set the setting in the app to talk the right protocol. Maybe not. Oh, yep, it throws a fault. Where's my phone? Communication fault, display 61 code on the inverter will cut off power if communication protocols don't match. You can select lib mode. So, I'm wondering if my cable's incorrect, or I'm not or I didn't latch the right protocol into the BMS, or I have to reboot the BMS. I'm not sure. I'm gonna have to go read the manual on this one. I don't know why it's set to this pylon 1. I'm gonna make sure pylon 1's the right one that this one talks. I'm gonna have to read the manual.